wabarakatuh. My name is Nurhana Saylina Binti Nazaruddin. I do a project under the supervision of Dr. Binti Ali, and I would like to propose my research project with the title of the effect of growth time on the crystallite size of zinc oxide structure by hydrothermal method. So the background of study in this project is about the semiconductor. Some example of semiconductor are silicon, germanium, gallium arsenide, and elements near the so-called metalloid staircase on the periodic table. After silicon, gallium arsenide is the second most common semiconductor and is used in laser diodes, solar cell, and others. Silicon is a critical element for fabricating most electronic circuits. The problem statement about this research project is the aqueous solution-based processing. So aqueous solution-based processing is commonly used to produce semiconductor nowadays, but even though it has many advantages such as low energy consumption, low expenses, and the morphology can be controlled and the broad production can be done easily, but aqueous solution-based processing requires a high temperature that makes it hard to control. There are two objectives in this research project. Number one is to observe the effect of growth time of the crystallite size of zinc oxide structure by hydrothermal method, and the second one is to investigate the optical properties of zinc oxide structures in different growth time. Two of the main points mentioned in the literature review are the zinc oxide nanostructure and also the effect of different growth time to synthesize zinc oxide structure. Zinc oxide nanostructure have seen functions in biology, scientific and medicine uses including dye-sensitized solar cell, lithium-ion batteries, biosensors, nano lasers and supercapacitors. Effect of different growth time to synthesize of zinc oxide structures is in the previous research has been done with the outcome of that the longer the growth time, the longer the length of zinc oxide structure. Hence, the length of zinc oxide structure is affected by the growth time. For the record, when the growth time of using hydrothermal method is longer, the density of nanorods also increases. For methodology, first things first, we need to prepare the solvent, and then we do the autoclave. For preparation of solvent, 2.5 gram of zinc chloride in 200 milliliter deionized water is stirred by using magnetic stirrer. The pH will be brings up to pH 8 by the addition of ammonium hydroxide solution 25%, and the mixture will be stirred for 1 hour at room temperature to achieve the homogenization. And for autoclave, the adjusting pH, which is the pH 8, will be transferred to the Teflon line steel autoclave with the temperature of 180 degrees Celsius in an oven for 2 hours, 4 hours, 6 hours, 8 and 10 hours respectively. Okay, this is the research flow chart. First, we need to prepare the raw materials and adjust the pH to 8. And then we do the autoclave and wait for the growth time. And then after that, we wash the precipitate with double distilled water and filter the precipitate and let it dry at 60 degrees Celsius overnight. And then we can do the characterization of the sample using XRD, X-ray diffraction, and UV vis spectroscopy. And last but not least, this is my Gantt chart for my research project. And that's all from me. Thank you very much.